Hello, welcome to Study Guide Forum. Today we'll be looking at a question that regards to um, this question has to do with Galileo's law, and you know that Galileo's law tried to study about gases, and he found out that gases they react in a simple ratio in a volume which is in simple ratio with one another, and one another, that is the reactants and also that of the product. So here we have some questions that has to do with that. Now in this question they said that we should find what the volume. Say that volume, sorry, 50 cm cube of hydrogen was explored with 20 cm cube of oxygen at 100 degrees Celsius at 1 atmospheric pressure. Calculate the volume of the total gases. Residual gases. We're looking at the total residual gases that it produced there. Now, the second question said 30 cm cube of carbon 4 combined with 10 cm cube of oxygen. Calculate the volume of the total residual gases. What am I doing here, Seth? All right. In this case, we are looking at the gases, the total residual gases that it formed. Now, before we do that, the first thing we should note here is that you should know the ratio of the reaction, and with the ratio of the reaction, we'll be able to know the one that is reacting in excess and the one that is reacting in that's limited. Sometimes we call it a limiting reagent. In this, there should be a kind of a limiting reagent in both reactants. So before we do this, before we calculate this, let's quickly look at the balanced chemical equation of what happened between hydrogen and oxygen. Now, between hydrogen and oxygen, we have the reaction. The balanced chemical equation is something like this. Now, in this balanced chemical equation, according to Lussac, we find out that in this case, we find out that 2 cm cube, because he said that they react in what? In volume, which is in simple ratio. In other words, 2 cm cube of this in the volume will react with what? 1 cm cube of oxygen to give us 2 cm cube of water. This is the 2 cm cube of water that we have here. 1 cm cube of oxygen combined with 2 cm cube of hydrogen will give us 2 cm cube of water. Now, based on this, now there's something you need to find out before you'll be able to get this thing done. Look, we have it at atmospheric pressure, 1 atmosphere, that is the pressure involved. We have 100 degrees Celsius. At 100 degrees Celsius, water remains as a steam, that is gas. We talk about the gas, the state. It means that all of them are what? Gases. Whatever is produced here at 100 degrees Celsius, water should be gas there. So now we are going to calculate this. Before we do this, we need to find out the gases that are the possible residual gases we are going to find out. We are going to see this as one of the gas, that is the steam, which is one of the gases that we are going to have there. Now, there are other gases that we're likely to find out, because if you look at this, we have 50 cm cube, we have 20 cm. That means one of them should be a limiting reagent. The limiting reagent now to calculate is by, we find out the volume. The one that produces the highest volume of steam is the one that is in excess, while the one that produces the lowest volume of steam is the one that is in that's the limiting reagent. That is the limiting one that's not enough. That will always determine what happened in this chemical reaction. So I'm doing this thing in order because I was going through my comment today. I found out that somebody is commenting on a similar question with this question which I've solved somewhere. I want to help the person. If you're watching the program, this video now, I want you to take this opportunity to go through it, and if there's anywhere you are not really getting clearly, help me by leaving a comment there. And then remember to share. If you really get everything, share so that your friends will get to know us. So pay attention as I go through this, and I really want you to understand, because you said in your comment that you don't really understand what you did not understand much, that I should learn how to explain more. So I'm trying to make it better for you now at this point. So now let's go ahead in our learning process. So here now we have, I said, like I said before, this is 100 degrees Celsius. That means we have steam, and in 1 atmosphere, that is also um, normal temperature. That water is always a steam. So the limiting reagent, now we need to find that one that is in excess and the one that is not in enough. That's not enough. So to do that now, you see that from here, from the balanced chemical equation, this we have 2 cm cube of hydrogen. That means 2 cm cube of hydrogen will give us 2 cm cube of steam. So if it's like that, that means 50 cm cube of hydrogen here will also give us 50 cm cube of steam, that is water. Now, for this other one, for the hydrogen, for the oxygen which is a 20 cm cube. In other words, 20 cm cube of, from what we have here, 20 cm cube of oxygen will give us 40 cm cube of water, because this is, we have 1 cm cube of what? Oxygen will give us 2 cm cube of what? Of water. So since it's that like that, that means 20 cm cube of oxygen, 20 cm cube of oxygen will give us 2 times 20. That will give us 40 cm cube. So it gives us 40 cm cube, meaning that hydrogen is in excess. So in other words, oxygen is not enough for this 50 cm cube of the hydrogen to react. So now we know the one that is in excess. This determines the approach we are going to use in solving this problem. It's going to help us in knowing how to solve the problem effectively. So let's quickly go down to what we have. So now we know the one that is in excess, and now we know the one that is not enough. So now let's go down to that. We have, from this chemical reaction, we are note that we are dealing with the ones that will be will remaining gases, that is residual gases, after the reaction has taken place. Now from this reaction, we notice that 1 cm cube, from our balanced chemical equation, 1 cm cube of oxygen will react with 2 cm cube of what? Hydrogen. I believe we are together in this case. 2 cm cube of hydrogen will be produced. We will combine with it. So if that is the case, 20 cm cube of oxygen, 20 cm cube of oxygen, which is this, will then react with 2 times 20. That will give us 40 cm cube of what? Of hydrogen. Now, which means, this thing means that at the end of this reaction, 20 cm cube of oxygen will be used up completely. Then for this 20 cm cube of oxygen to be used up, it will require 40 cm cube of hydrogen, which is coming from this 50. Then if that 40 cm cube is used up from the 50, what is remaining? We have 10 cm cube. Now we can say, now we say, remember, 50 minus what? 40 will give us 10 cm cube. That is 10 cm cube of oxygen. Of hydrogen will be part of our residual gases. We can pen it down here so that we won't forget. We won't clean it up. We have one of the hydrogen gas. This is hydrogen gas 1. The 10 cm cube of that will remain. So the next gas that will remain at the end of this reaction is that steam, because this is in what? 100 cm cube. This is 100 cm cube. 100 degrees Celsius, sorry, and then 1 atmosphere, that means it's steam. So based on what we know from here, what we have done before, this is 2 cm cube cube, 1 cm cube of oxygen will give us what? 2 cm cube of water or steam. So 20 cm cube will also give us what? 2 times 20, which will be 40 cm cube. That is what we have here. The steam that will be produced is 40. So the total residual gas that we have there will be this 40, which is steam, is still a gas, water in form of a vapor now, water in vapor state, that is a gas, plus this 10 cm cube of remaining hydrogen will give us 50 cm cube. 50 cm cube of what? Gases, residual gases. That is what we have in this case. This is what we have, 50 cm cube. I believe that this one is all right now. So we go over to the second one we have here to make it a bit, to digest it more. So what we have here, what we have there is, say that 30 cm cube of carbon 4, carbon, is it carbon 4? Oh, it should be carbon 2. Carbon 2 oxide combined with 10 cm cube of oxygen. So say calculate the volume of the total residual gases. Now, in the same way, before we do that, we need to find out the we look at the balanced chemical equation, which will be like this. So this is a balanced chemical equation, almost similar to the volume ratio of it is also almost the same thing. We have 2 cm cube, we have 1 cm cube, and then 2 cm cube. Now with this like we did before, we need to find out the one that is reacting in excess and the one that is limiting. Now the limiting reagent, that if you find out this one give us 30 cm cube of carbon 2 will give us 30 cm cube of carbon 4, and then while 10 cm cube of oxygen will give us 20 cm cube of carbon 4. That means oxygen is the less, while carbon 2 is in excess. So that means at the end of the reaction, we find out that some volume of carbon 2 will remain. That is part which will be part of our chemical part of our residual gases. So let's go down to that. Here we have 1 cm cube of oxygen will give us 2 cm, we react with 2 cm cube of carbon 2. If it's so, the next thing we have here is that 10 cm cube of oxygen will also react with 2 times 10. That will give us 20 cm cube. 20 cm cube of what? It will react with 20 cm cube of carbon 2. So this is what we have. That means at the end of this reaction, 20 cm cube of carbon 2 from here will be used up, while 10 cm cube of here, all of them will be also used up. Then if they are used up, what is remaining in this place will be 10 cm cube of what? Of that carbon 2. Carbon 2, we have 10 cm cube remaining. So if it's 10 cm cube remaining, then the next thing that we'll have here is the residual, the gas that is from carbon 4. Now, if we find out from a chemical reaction, what will also be produced will be the carbon 4 that will be produced at the end of the reaction will also be 20 cm cube of carbon 4. This 20 cm cube of carbon 4 that is produced from this reaction, 20 cm cube plus 10 cm cube will give us 30 cm cube of what? Residual gases. So that may happen to be the answer of this question. Thank you so much for being part of it. And this question here will be in the description of this very video. And I want you to do us a favor by subscribing to our channel, share, and then if you have any question, you can leave it as a comment there. Thank you so much.